Okay, boys and girls, we're going to finish the notes from Friday. We're on page 13 in your packet. We're just going to go ahead and finish those notes. So we learned on Friday that first thing we do is a direct substitution and see if it is in one of the indeterminate forms. So we can see when we do the limit as x approaches 1 of x over x minus 1, we get 1 over 0. So that means that it's going towards infinity. So we have infinity. And then if we do the limit, it's going towards infinity. We do the limit as x approaches 1 of 1 over natural log of x. Natural log of 1 is 0, so that one's going towards infinity as well. So we have infinity minus infinity, which is indeterminate. So we know if it's indeterminate, then we have to put it in the form of infinity over infinity or 0 over 0. So to do that, I am going to make a common denominator. So I have x, natural log of x, minus x minus 1 over x minus 1, natural log of x. And doing the limit as x approaches 1. So if I do the limit as x approaches 1, the natural log of the natural log of 1 is 0. Sorry about that. The natural log of 1 is 0. So this is 0. And x minus 1 will give me 0 as well. So I have 0 in the numerator. X minus 1 is 0 times natural log of x, so that's 0. So it's in the indeterminate form of 0 minus 0. So then what I need to do is take the derivative of both sides. So the derivative of x, natural log of x, I have to use product rule. So I'm going to keep x the same and take the derivative of natural log of x. Plus, I keep the natural log of x the same and take the derivative of x. And that would be minus 1. And then here, of course, I have to use product rule again. I am so sorry that it keeps doing that. So then the derivative of x minus 1 is 1. So that would be natural log of x plus x minus 1 times the derivative of natural log of x, which is 1 over x. And if I were to clean that up, this goes to 1. So I have 1 minus 1 is 0. So we have the limit as x approaches 1 of natural log of x over, let's get a common denominator there again. We get x, natural log of x, plus x minus 1 all over x. And if I simplify that, bringing the x to the top, I get the limit as x approaches 1 of x, natural log of x, over, this is getting on my nerves, x, natural log of x, plus x minus 1. Okay. Once again, I'm going to do a direct substitution. I do a direct substitution. I get 0 on the top and 0 on the bottom. So once again, I have to use L'Hopital. So using L'Hopital again, I get the limit as x approaches 1 of x times 1 over x plus natural log of x over that's going to give me 1 plus the natural log of x, because that's the same thing I have on the top, plus 1. Now, doing a direct substitution, I get the limit as x approaches 1. I get 0 on the top again over 2. And I've done something wrong. Oh, I'm sorry. The limit as x approaches 1 is 0 here. But here, that's just going to be 1. So that's 1 plus 0, which is a half. Yay! So the answer is a half. which is really, I shouldn't have written that limit there, but the answer is a half. Okay. Alrighty, let's try this one. Again, for this one, we're going to have to use logarithmic differentiation somewhat. We're going to set y equal to the limit as x approaches 0 of 1 minus 2 to the x, 1 over x. Why did I do that? Let me make sure I can do that. If I do a direct substitution of 0, I get 1, and 1 over x is going to give me infinity. I have 1 to the infinity, which is indeterminate. Okay? Indeterminate. So now I have to make it so that I can get it either at 0 over 0, infinity over infinity. So by taking the natural log of y, I get the limit as x approaches 0 of 1 over x, natural log of 1 minus 2x. So when I take the limit as x approaches 0, I now have 0 over 0, because if I do a direct substitution, 2 times 0 is 1. 2 times 0 is 0, new math. So the natural log of 1 is 0, and then I get 0 over 0. So that is in indeterminate form. So I have to use L'Hopital. So I get the natural log of y is equal to the limit as x approaches 0 of, I'm just going to rewrite this, 1 minus 2 over x, and we have already determined that we can use L'Hopital on that. So that gives us the limit as x approaches 0 of negative 2 times 1 minus 2x. I use chain rule on that, all over 1, because I'm using L'Hopital. So I'm taking the derivative of both the numerator and the denominator. On the numerator, I use chain rule. I took the derivative of the inside function, which was negative 2, and then it's 1 over 2 minus x. So now I can see I can do a direct substitution here, and I get the limit as x approaches 0 is of negative 2 over 1 minus 2x, and that's going to equal to negative 2 over 1. Okay? But that's not my answer. Remember, that is the natural log of y is equal to negative 2. So then I solve for y. I get e to the negative 2 is equal to y. So my answer is e to the negative 2. Okay. Let's finish this one up. Oh, I'm sorry. Let's finish this one. Again, if I just do a direct substitution, the square root of infinity, x squared plus x is going to give me infinity. So I'm going to get infinity minus infinity. That's indeterminate. So I have to put it in either x over x, 0 over 0, or infinity over infinity. So now, what should I do? I'm going to multiply by the conjugate. So x squared plus x plus x. I know some of you are asking, how did I know I was to multiply by the conjugate? Because I couldn't think of anything else to do. Does that work? So in the numerator, I get x squared plus x minus x squared over the square root of x squared plus x plus x. So simplifying that, I get the limit as x approaches infinity of x over, excuse me, I have no idea what happened there, sorry, of x squared plus x plus x. Okay. So what do I do with that? The limit as x approaches infinity. Alrighty. Well, I'm going to have to use a little bit of intuition with this. If I do a direct substitution, I get infinity over infinity. But what I'm going to notice is that with this radical, that radical will never go away. I'm going to continue to get that radical in my answer. So I'm just going to go ahead and use some intuition to do that. We've talked about this earlier. So if I take the limit as x, so the limit as x approaches infinity of the square root of x squared plus x. Recall that as this goes towards infinity, this becomes negligible. And the limit of the square root of x squared we talked about earlier is the absolute value of x. Okay? So I have the limit as x approaches infinity of x over the absolute value of x plus x. Now, since this is going towards infinity, the absolute value of x is just going to be positive anyway. So simplifying this, I can write this as the limit as x approaches infinity over x 2x. Okay? Because since this is going towards infinity, the absolute value of x is just going to be x. So I have x plus x 2x, so this limit is 1/2. Okay. Last one, and this is another one we have to use log differentiation, I think. Cotan of x as x goes towards 0 is infinity, right? Because it's cosine over sine. So you have sine in the denominator, that's going toward 0 in the denominator is going to go towards infinity. And 4x would give me 0 plus 1. So I have 1 to the infinity, and that is indeterminate. Okay, so then when we have them like this, when we have it raised to a function, we want to do y is equal to the limit as x approaches 0 from the right of 4x plus 1 cotan x. Then we're going to take the natural log of y, the limit as x approaches 0. We're going to take the natural log of this, which is called cotan x, to drop, and then we have the natural log of 4x plus 1. I want to put this in infinity over infinity, or 0 over 0. So I can write this as the natural log of y is equal to the limit as x approaches 0 from the right of natural log of 4x plus 1 plus, let's say tan x, right? Okay, so as we go towards 0, we get the natural log of 1 over tan of 0, which is 0. We get 0 over 0. L'Hopital applies. So once again, we can do the limit as x approaches 0. I'm taking the derivative. Using chain rule, I get 4 on the numerator and then 4x plus 1 in the denominator. And then the derivative of tan x is secant squared x. Okay, so now I'm going to try direct substitution again. This is no longer 0, so this is going to give me 4 on the top. And secant squared of 0 is 1. So the answer is 4, but again, that's the natural log of y is equal to 4. So e to the 4th is equal to y. Okay, I think that's it. I hope you guys have an amazing day today. I'm sorry I'm not here today. Yes, you have your quiz tomorrow. Oh, let me show you one more thing. That was on your last test. And I think on your last test, it was the sine to the third of x. And they ask you to integrate that. And a lot of you missed this. It was one of the most missed questions, so I just kind of want to go over it. We can write this as sine squared of x times sine x dx. And sine squared of x would be 1 minus cosine squared x times sine x dx. So we're still going to have to use a u substitution on this. So I'm going to let u equal to cosine x. So du is equal to sine x dx. And we have that in our problem already. So this becomes 1 minus u du. So integrating that, I just get u minus 1/2 u squared plus c. Well, what was u? U was cosine x. So this is cosine x minus 1/2 cosine x. Did I do that right? I didn't do that right. If u is equal to cosine x, then du is equal to negative sine x. So this should be a negative out here. So this is negative and that's positive. So this is negative, and this is positive 1/2 cosine x plus c. Now, you probably think I told you that for a reason, and I probably did. So hold on to that thought. All right, guys, I will see you tomorrow. You will have your quest tomorrow. And okay, that's it. Bye.